Welcome to a brand new chapter called S2 on discrete random variables. Typically the second statistics chapter that you will learn after permutation and combination and probability. So to give you a broad overview of this entire chapter, I'll first explain a couple of terms that we will use every single time throughout this chapter and paint a picture for you so that you get a sensing of what this whole chapter is really all about. Okay, so this chapter is called discrete random variables. So first and foremost, let's start off with something that you already know. You have this word called the variable. Now, you know that the meaning of a variable is that it can take on a range of values, right? So can take on a range of values, right? Or you can think of it as, it can take on many different kinds of values, right? So we have a variable. Now, when a variable, the value of a variable happens by chance, right? So now I'm just going to draw a line down here, right? So the value that a variable takes on, right? When it happens by chance, then this is what we call a random variable. Okay, so the word random comes in to describe the variable, right? Because the value that it takes on is by chance. Now, when we have a random variable and it takes on a value, there are two types of values in this world, very broadly speaking, right? And these two types of values are your discrete values and your continuous values. So what are the difference between these two? There are a lot of ways that people use to describe these two terms, but just a rule of thumb, discrete is something that you can count, right? For example, 1, 2, 3, 4, 5, 6, 7, 8, right? Those are discrete numbers. But continuous numbers, they are something that you cannot count. So you cannot count. Very simply put, for example, height, right? You cannot say that I am 178 cm because my height is never truly 178 cm. It's 178.012876, right? It just goes on and on and on. There's a decimal to it, right? We can never get the precise value. And what are some examples of continuous values? Would be the height of students in your class, right? Even though you and your friend, both of you might be 160 cm, but y'all are never truly the same height. That's simply because when we actually measure the true height by X number of decimal places, one of you will be taller. But for discrete values, it's something that we can really count. For example, I have one pen, right? This is literally just one pen. It's not 1 point something pen, it's one pen. So in this whole chapter, we'll be talking about random variables that are discrete. So it brings on the concept of discrete random variables, which is the name of this topic. Okay, so I have just painted the picture for you as to what this whole topic is going to be about. So let's talk about the first concept, and that is a probability distribution, typically represented in the form of a table, right? So over here, it's a table. Now, what does this table represent? As the name of the concept suggests, it represents the distribution of probabilities of a discrete random variable. So if this is your first time learning this topic, my previous sentence would have probably confused you a lot. So let's just paint this whole idea with an example again. Okay, so let's look at this. Imagine this, right? You have a dice. So just put an example here. For example, you have dice. And we know that a dice, a fair dice, a normal fair dice, has 6 sides, right? So a dice will have 6 sides. So we have one side, 1, 2, 3, 4, 5, 6, right? These are all the different values that the dice can take on, right? Depending when you roll it and then you look at the top of the dice, right? The value is either going to be one of this, right? It has to be between 1 and 6. So let's define the random variable first. So I'll say let x, and typically for this chapter, we'll use the capital X, right? We don't use the small x over here. We use the big X to denote that it is a random variable. Okay, so note that in this whole topic, from here onwards, this over here is in capital notation, right? It's just a way that we express it so that we know it's a random variable. So let x be the value, or okay, let's just use the term that we use, the random variable that represents the number on the top face of the dice after each row. Well, I believe I could have wrote this sentence a lot shorter, but you get my idea, right? So x over here is the random variable, and it can take on all these different values. So if I were to draw a table over here, right, this is x, then I will draw a line here, and then I draw a line down here, and then this is 1, 2, 3, 4, 5, and 6. So over here, this is the random variable because it can take on many specific values. And each one of these are specific values. So for specific values, we will use the small x value. So this one over here is x equals to 1. This over here is x equals to 2. This over here is x equals to 3. And then so on and so forth, right? X equals to 4, x equals to 5, x equals to 6. So note that for specific values, values, this one is in small caps as it's a specific value. Okay, note that if it's specific value, it's a small letter. So what is the probability of rolling a fair dice? Okay, I'm just going to put the word here, fair. So if we roll a fair dice, we know that each side has an equal probability of being chosen. And that's why for the probability, right, so P, that X, the big X value equals to the small x value. Okay, so when I write it this way, I'm saying the probability of my random variable being the value of the small x, which is essentially this over here, is going to be 1 over 6 for each, right? So this is 1 over 6, 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 and 1 over 6. So what I've just done is that I've created a table that summarizes the distribution of all of the different probabilities that my x, which is a random variable, can take on. And this is what we call the probability distribution table. Okay, so this is the first concept that we need to know, because sometimes in the exam they will ask you to draw the probability distribution or represent the distribution of the probability, and it will usually be represented in a table for discrete values. Okay, so you don't need to know so much. We just know that it's for discrete random variables. Now, so before we end off this fundamental concept, I want to just go through two basic things that you already know by now. So for x is a random variable, right? We know that x over here can take on many different small x values, right? So can take on many different small x values each, right? They are all discrete. So the probability of big X taking on a specific small x value will always be bigger than or equals to 0 or lesser than or equals to 1, right? This is something that you already know. And if it's 0, this is an impossible event, right? This is the event. And then this one over here is a certain event. Okay, so this is the first thing that we, pretty much already know. Now, the next thing would be for all of these values over here, right? You realize that every single one of them, they all add up to 1. So that is true because when we add up all of these individual probabilities, they have to add up to 1, because we know that certainly my big X has to take on a value from either one of these 6 values. So when we sum up, so this one you probably know the notation already. When we sum up all of the different probabilities of X over here, right, from the table, we will always get 1, because what we are doing is that we are summing up all the different possible discrete values probabilities, and you will always add up to 1 because it cannot take on any other value apart from the values that are inside the discrete range, right? So that is essentially the concept behind this. So this is the whole idea behind probability distribution and what this whole chapter is about. So once you get the idea of this, feel free to retract and watch this video as many times as you need. But once you get the idea of it, let's just jump right to practice. So this over here is a question. Feel free to pause this video right now to attempt this question, and when you're ready, you can unpause it because we're going to start to debrief this question right now. So we have a fair coin, and the word fair here is very, very important because this word fair suggests that the probability of each side is the same. So we know that a coin has 2 sides, either heads or tails, right? Heads, tails, and the probability of each is half. So it's tossed 3 times in succession. Let x be the number of hits obtained. Tabulate the probability distribution of x. So again, whenever we see the word probability distribution, it will be in our best interest to draw the table because it helps us to visualize what are the different probabilities and also to check our work. But before we draw the table, let's just try to draw a simple tree diagram to map out what are the different possible values. So we know that when tossed 3 times, so this is the first toss, this is the second, and then this is the third, right? Now when you have the first one, you have heads or tails, like that. And then when you toss it again, you can go heads or tails, and then you toss it, you can go either heads or tails again. And then last but not least, here, you have heads or tails, 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 right? So each different branch has a different number of hits, right? Because now our discrete random variable is measuring the number of hits. So note that depending on what is defined by the question, that is pretty much gives us the focus of the question. So for this whole branch over here, right, we have 3 hits, right? So if I just follow this branch here, I have 3 hits. Now if I follow this branch over here, I have 2 hits, right? And then for this branch over here, I have 2 hits because I'm just tracing it like that, and then like that, right? That's the only possible way. Then of course, when I do this again, I realize that over here, I have 1 hit. And then when I do this again, I have 2 hits. Do this again, I have 1 hit. Do this over here, I have 1 hit. And then last but not least, I do this here, here I have 0 hits, right? So you can see that my x value, right, can take on 4 different possible values. So we know that my x is the random discrete variable, so x over here, and it can take on a few values, right? It can take on 0, take on 1, it can take on 2, it can take on 3, right? Because you see that I can have 3 hits, so 3 hits means that the number of hits that I get is 3. I can have 2 hits, right? These are all 2 hits, and that means that my x value can take on a value of 2, because at the end of the day, x represents the number of hits after 3 times of tossing. You get the idea? Now, 1 hit means that x could take on a value of 1, and 0 hits means that x can take on the value of 0. So when I draw a table like this gives me all the different possible values that x could take on, right? You just draw a simple table like this, of course with a ruler when you're actually doing the question. So now, what are the different probabilities associated with the x, right? Over here, I have 1 possibility of 0 hits. So this is 1 out of 1, 2, 3, 4, 5, 6, 7, 8 different outcomes, right? How many times does x get 1 value of 1? You see that x has 1 3 times, right? So this is 3 out of 8, right? Next, how many times does x have 2? So you see that it has 1, 2, 2, 2 over here, right? That gives me a value of 3 over 8. And last but not least, you have x equals to 3, and that will mean that here is 1 over 8, right? So this is what we have so far when we draw the probability distribution. At this point, some of you might be confused. You might be thinking, why isn't it not just like half times half times half, right? Why isn't it not 1 over 8? And the thing is that you are not wrong, but the question is asking for the probability distribution of x, where x is the number of hits obtained. So the focus is the number of hits obtained. We are not concerned whether it's HHH, or we are not concerned whether it's HTH, or like HTT, right? We don't care about whether it's HTT or HHT. At the end of the day, we just care about how many hits do I get, right? So what we do is that we look at each individual branch and each individual leaf at the end of it all, and then we count the number of hits that got us there, and then we count the number of hits, and then for each outcome, we just count the number of hits, and then we group all the results inside this table over here. So the question is asking, what's the probability of x is bigger than or equals to 2? So for x is bigger than or equals to 2, I have a possibility of x equals to 2, or a possibility of x equals to 3, right? Because bigger than or equals to 2 means that x can take on the value of 2 or 3, and that would mean that it's 3 over 8 plus 1 over 8, which gives me 4 over 8, and then we can reduce this to half. Next would be p 0.8 bigger than or equals to x smaller than or equals to 3.2, and for this is very straightforward, because we know that x cannot take on any decimal values, right? We know that x has restricted to only these 4, so we just need to know or count which values actually fall within this range, right? Between 0.8 and 3.2, and that will mean that it's this value, and this value. So all we got to do is that we just got to add up the possibility of it being 1 or 2 or 3, right? We just add up all of this, and in the end we get the value of 7 over 8. That's the final answer to this question over here. Okay, so this is the end of the part 1 to this whole chapter. Let me know if you have any other questions in the comments below. If not, this is a very good question to just kickstart the chapter and give you a basic platform to practice your new knowledge. If not, I'll see you in the next video for the next concept.